Okay, so for this next part, what we want to do is we want to compare the density that we calculated to the density of silver. All right, now, unfortunately, we made a little boo-boo, and by we I mean I made a little boo-boo, but let me just kind of show you. Okay, so now this is the density, the mass per unit volume. Remember, the masses in grams, volumes was in cubic millimeters, and I'm going to go back to a list of the elements that I got. And now, of course, I got this from Wikipedia, shame on me, but it was nice and handy and available. Now, if you go there, you're going to notice that silver, atomic, it has a weight of this, okay, and its density is 10.501. All right, its melting point is 1234. Okay, but its density is 105. Okay, 1.0501. Now, if we go back to my Excel spreadsheet, I'm just going to pop this in here, paste. Whoops. And it did not. I'm going to have to change the color so you can see it. Let's change the color to something we can read. Boom, black. There we go. That's the density of silver. Now, if you take a look, there's something very, very radically wrong here, because this is 10 and this is 0.0009. Okay, so that doesn't make any sense at all. Well, it makes perfect sense when you consider the density is usually calculated in grams per cubic centimeter, and we did cubic millimeters. Well, it's very easy to figure that out. Okay, all we have to do is multiply. Since there are 1,000 cubic millimeters, there's 10 millimeters in 1 centimeter. There's 100 square millimeters in 100 square centimeters, and there's 1,000 cubic millimeters in 1 cubic centimeter. So all I have to do to get this in cubic centimeters is go equals this times 1,000. All right, and so now when we bring this all down all the way, what we discover, whoops, there we go. What we discover, okay, and we have to expand a little bit. When you ever get those number signs, it means there's not quite enough room. All right. We discover is actually we had a weight of 10, and this has a density of 9.7. Well, that's actually not too bad. They're not off by a whole heck of a lot. At least this one wasn't. All right. However, there is a couple of other things you have to consider. All right. And one is, well, let's go actually see what Morgan silver dollars are made out of. All right. We said there was silver. Okay. The density of pure silver is 10.5. And this has a density of 9.7. I wonder if there's an explanation for that. Let's go take a look at, back to Wikipedia, of course, what it says about the Morgan silver dollar. And when you slide across, all right, I'm just going to kind of hold it up so you can see it. If you look, it actually talks about the design, and what it tells you is, the Morgan silver dollar is only 90% silver. It's 10% copper. So let's see if we can calculate what the actual density of a Morgan silver dollar should be, and then we'll see what we actually got. All right. The other thing you'll notice, it also has a diameter here, which is kind of interesting. They say it's 3.81, and these guys said it was 35. Some people said it was 35. These guys had 38.9, 38.8. So these guys actually were the closest to the actual diameter. All right. So anyway, why don't we see if we can calculate what the actual density of silver is? Well, there's a the silver dollar is. Well, there's a very actually simple trick for doing that. All right. But I'm going to go to a new sheet. So I'm going to go insert a worksheet. Okay. And what we're going to do is the density of silver, and I'm going to make this bigger so that you guys can see what I'm doing. Density of silver, and the density of silver is, let's go back to the Wikipedia that talks a list of the elements. Silver is Ag. Right here, and its density is 10.7, 10. 10.51. And the other component is copper. So the density okay. Now you're going to really love this because this is very, very handy. Density of copper. All right. The density of copper, let's go back to our little list of elements. Copper is Cu. Copper, its density is 8 if you take a look at this all the way across, its density is 8.96. So that's a kind of a hopeful thing. Boom. All right, and if we take a look back at what it told us, the Morgan silver dollar is actually 90% silver and 10% copper. So let's see what these things equal. Well, what percentage of the weight comes from silver? Well, 90%. So its density, the weighted density is going to be equals this times 0.9. And the amount of weight coming from the copper equals this times 0.1. And so when we add these two numbers together, okay, if we just sum them, which is what this button does, we get a density of 10.4. All right. So what we discover when we look at this is, whoops, what we discover when we go back to the Morgan silver dollar is the weight we got was this. The actual density should have been 10.4. Okay, so we were a little bit off. All right, but for the most part, I think that that's actually, it's at least within striking distance, the right order of magnitude, so it wasn't really too bad. All right, so what we're going to do is we're going to calculate the density for all the different for all of the different types of bills, and then we're going to see what their densities actually should have been. All right, if we take a look at this again, the density, whoops, turns out to be this. Okay.